In this video, we're going to be specifically talking about percent decrease problems. Let's look at number 1. It says Katie's wealthy grandfather gave her $500 for a birthday present. Gramps told her that she can only spend 15% of the balance each week. So she starts off with $500 and then she spends 15%. So that means that this $500 here is going to be going down each week. So it's going to be a percent decrease problem. For the recursive formula, we have U sub O is how much we start off with. In this case, she starts off with $500. And then we have any term, U sub n, equals the term before it, which is represented by U sub n minus 1 times 0.85. The question is, how did we get 0.85 when it says we're spending 15%? Well, we have two types of problems. We have percent increase and we have percent decrease. So there's increase and decrease. It's either going to be 1 plus if it's increase, or it's going to be 1 minus the percent if it's percent decrease. So in this case, since we're spending 15%, that means our balance is decreasing. So we're going to do the percent decrease and do 1 minus 0.15, which gives us 0.85. If our balance increased, then we do 1 plus 0.15, which is 1.15. So we either have the growth factor, which would be 1.15, or we'd have a decay factor, which is 0.85. Right, think about it in terms of shopping. If you wanted to take 15% off, if you had a 15% off, you're like, okay, I'm going to multiply it by 0.15 and you'd get 75. But if a product was worth $500 and you took 15% off, it wouldn't be $75. You'd have to do something with that 75, right? You would take the 500 and you would subtract it from 75, which would give you the 425. But instead of doing two steps, 1, 2, you could also say, if I want to take 15% off and the purchase price was $500, you could just multiply that $500 by 0.85 and it'd give you the $425. When writing our explicit function, we have to determine our input and our output variables or our independent and dependent variables. So for this problem, it says that we have, or Katie now has $500 in her, we'll call it her birthday present account. So we'll say A for her account, and she can only spend 15% of the balance each week. So the input is weeks. How much money does she have after a certain week? So we have A of W equals our initial amount, how much we start off with, $500, times 0.85, and then our input variable is W. So remember, for the order of operations, we have to do the exponents first. So for this next problem, when it's for letter C, use your model to find the money remaining after 10 weeks. For W, we're going to input 10. Okay. Again, you do this part first. So you have 500 times 0.85 to the exponent 10, which is about, if you rounded it to the nearest hundredths place, we'd get 0.20. So we'll put these squiggly lines for about. And if you multiplied 500 times 0.20, you'll get about 98.44. So it would be about $98.44. And you do the same thing for letter D, but instead of 10, you'd use 15. For letter E, it says use your model and a calculator to estimate the number of weeks it will take the amount to drop to only $20. So this time they give you how much is in the account, and you have to find out how many weeks. So we 20 equals 500 times 0.85 to the exponent W. So we have not learned how to find W where the missing variable is an exponent, but it will help you realize that there is a need, a need or a way to be able to find that exponent. But right now we're just going to simply use our calculator to guess and check. So if you can pause the video and try to find out what number would go there. And you should have gotten W to be about 19.8062.